The fitting is not a straight line anymore. It's going to have some curve, okay, turning, and then you can decide your degree. Can be degree 2, 3, 4, and so on. Okay, but do not put too high degree. Okay, because too high degree, it may cause overfitting. Okay. So even sometimes you have a 3 point like this only, and then you ask for degree 3. Okay, actually, we know this 3 point, we can actually use the simple linear, a straight line to approximate it. Okay, but if you you insist to use degree 3, okay, the system can obey to you, then it will make a turn like this. Okay, you will measure it, you will passing through this 3 point as well. But this one already something extra. You do not need this. You can just use the straight line will do. You will just pass through this 3 point. Okay, it doesn't mean that higher degree you get a better result. Okay, no. If you do not need higher degree and then you put the higher degree, then you first you create a problem like overfit. Second, you create the problem that the system have to cater with the more calculations. Okay, so it's something not good. So do not overfit, do not use the higher degree if not necessary. Okay, so this is the pros and cons. Okay, so for the linear regression, it works on any side of data set, give information about relevant features. Okay, the cons is the linear regression assumptions. Okay, you have to set there. It's a linear line. Polynomial regression, it works on any data set also, okay, and very well on the nonlinear problem. But you need to choose the correct degree, okay, else the result won't be good also. So the techniques having their pro and cons, so you have to make our adjustment and decisions. Normally, the decisions can come from the accuracy. So that's why there's one section you are going to learn is on the studying how good the model is. Okay, so the regressions part is done. So we are going to move on the second technique, the second model, which is called classification. So today you learn 3 models. Just now is regressions. Okay, now we have a classification. The last one will be clustering. Okay, so what the classification is? Okay, classifications is to classify the data you have. Okay, so for example here, okay, so all these are apple. We already label them as apple. Another set here, we already label them as orange. Okay, so we already have some idea how the orange look like. It's a circle, orange color. Okay, how the apple looks like is a circle also, but having a red color, okay, maybe green color or yellow color a bit. Okay, so based on this, so when we have this data, then it's a red mark circle, so it's more close to apple. So it will categorize it into apple and tell you this picture is actually apple. Okay, and for orange, the features you have is circle and orange color. Okay, so all right lah. This is circle, orange color, then you will classify into here. Okay, and I have another one here. Okay, circle, a bit orange, a bit yellow, a bit red. So it may confuse. What should this belong to? Okay, so in the classification model, even though you have not seen it before, then it will make some calculations on this. Okay, so you will calculate this picture, okay, with the probability 0.6 looks like apple, 0.4 look like orange, then it will classify it into apple as well. Okay, so this is something that have not seen, but it try to classify based on what it have learned before. Okay. Okay, so for the classifications model is normally to predict the category, not the number. Okay, if you want to put the number, you always think on regression techniques. Okay, just now what you have learned are all on predicting the number. Okay, so now you want to learn how to predict the category. So I will go through a few techniques with you lah. I have 6 here. I try to cover as many as possible. If can, I will cover all the 6. Okay, looking at the time lah. Else we have to study until 7 o'clock later. Okay, so I will start with naive Bayes and logistic, then followed by KNN, SVM, decision tree, and random forest. Okay. Oh, actually, the techniques later on you will see the Jupyter notebook, the code that we are going to write is quite similar, just like what you have done for regression. Then you can see you only change the file name, you change the location of XY, then you change a bit on the fitting part, then the rest will be the same. Same idea as here, huh? You have just make some changes. Okay. So first, we look at naive Bayes. Huh? Okay, naive Bayes is actually a family of probabilistic algorithm. So it's very much depending on the probability calculated. Okay, and it is used to predict the category using the probability theory and Bayes theorem. Bayes theorem is relevant to probability theory as well lah. Okay, they do some summation, multiplication, and so on. Okay, so in these techniques here, the probability for each category will be calculated. So just now you have apple and orange, so it will calculate the probability, okay, for it to be categorized as apple, probability for it to categorize as orange. Then you compare which probability is higher, then you will make the prediction. Okay, the new picture should be go under apple or under orange. Okay, so you will follow the highest probability. Okay, so I'm going to explain this further using an example. Okay, so there is a data set below here. Okay, it's a collection of information where a person will go to work by car or LRT according to their age and salary. Okay, so there's a survey. This age with this salary will go to work by LRT. This age with this salary go by car and so on. So okay, you have a set of data here. Okay, so your target is what? You want to predict a 30 years old people, salary is 6,000. So this person will go by car or LRT. So this data of 30 years old and 6,000 salary, it may not happen or it may happen before in your survey. We don't know. Doesn't matter whether it happened or not happen in the survey, doesn't matter. Okay, we still can predict this person will go by car or LRT. Okay, so we are going to build a model by using the survey result that we have. Okay. So you can see what happened here. I have age, I have salary. Okay, and the red car, the square box here is go by car. Okay, and then the blue dot here is go by LRT. Okay, and then the new data given is 30 years old and 6K. So it's a red point here. So this red point, this person will go by car or go by LRT. Looks like LRT, also looks like car. Isn't it? Okay, so if you use the naive Bayes techniques, okay, then it will calculate this red color people, okay, the probability by car and probability by LRT. And then you will see which probability is higher. So how to calculate the probability on this? Okay, we want to calculate this probability. So first, you have to find the probability this person go to work by LRT, and you have to find the probability this person go by car. Then you make a decisions based on the highest probability among these two. Okay, the formula involved is like this. Okay, the straight line means given probability go to work by LRT given that person. Okay, and probability S given LRT, probability LRT divided by probability X. Okay, so this is the probability we want to calculate, which is the posterior probability. This posterior probability It depends on the three probability in the right hand side here. Okay, so how to get the three probability in the right hand side here? So you'll come back to this diagram with all the data. Okay, the probability LRT is very easy to calculate only. So the probability LRT, we just count how many LRT, okay, out of total number of observations. So total number of LRT, you just count how many blue dot, they are 10. Out of total is 25. Okay, so very easy to get the probability of LRT. So this one done. Okay, next one is the probability of that person. Okay, the probability of that person, the red dot, probability of the red dot to happen. Okay, probability for the red dot, how to do? We'll draw a circle. Okay, this circle is not necessarily very big. Okay, but this circle have to consist of both LRT and car. Okay, so you can see inside we have car, we also have LRT. Okay, so inside here we have actually three observations lah. Okay, three observations out of total observation. So it's 3/25. Okay, so we get the PX. Okay, so one more probability is the X. X is the red dot, probability of the red dot given that it is under LRT. Okay, so we will observe from the same circle again. So you will see how many LRT inside. There are 2. Okay, 2 out of total LRT is 10. So 2/10, you get 0.2. Okay, you multiply up these 3 probability lah, and then divide by these 2 probability and then divide by PX. You will get the probability going by LRT given that the person X. The straight line here is given in the probability. Okay, you already know that person, the red dot, you want to know that you will go for LRT. Okay, so it depends on these 3 probability in the right hand side. Now we have found all these 3 probability. You combine them together, so you can see the answer is 0.67. Go by LRT is 0.67. Then how about go by car? Probability go by car, you can solve it in the same method lah. Okay, then you will end up with 0.33. Actually, I no need to go through all the process. I only need to calculate for probability LRT will do is already exceed 0.5. So another one will be less than 0.5 for sure. Okay, so that means probability go by LRT greater than probability go by car. So you can make a conclusion, the person will go by LRT. Okay, so this I just want to bring out the information that neighbor is very much depending on the probability. That's it. Okay, but anyway, when you build out the model, you are not going to draw all this lah. Okay, this one is actually for the understanding only. Okay, so for neighbors, if you cannot really understand what I have given on the conditional probability on all this, it's still fine. Okay, but what you have to remember is neighbors very much depending on probability. Okay, and then this probability you can ask Python library to calculate for you. Okay, and the thing you need to know is how to import the data set, how to put in the data set into the model. Okay, naive-Bayes model. And in naive-Bayes model, there are 2 types. Okay, popular 2 types, which are Gaussian and Bernoulli. Okay, if your data involve the continuous input. Continuous input means it's a value lah. It's a value, okay? It's not the discrete type. Because in the variables under probability, when we talk about random variables, those variables can be either continuous variables or discrete variables. Continuous variables is normally a value with decimal places, like a range, okay, 0 to 1. Then you can get 0.1, 0.2, 0.3333, 0.45, a lot of value, right? In between. That one is called continuous. Okay, so if my data set is a continuous data type, then I better use Gaussian. Okay, if they are discrete, which means only based on yes or no, raining, not raining, okay, go out, not go out, then I can use Bernoulli. Anyway, the output you get, you will realize that not much different. Okay, so can you get some basic idea on what Naive Bayes is? Okay, so you can classify that person will go by car or go by LRT by calculating the probability. Okay, so this will be catered by Naive Bayes classifier in sklearn. Okay, so in this part here, you can see we just have to fit this model, Naive Bayes model, into our data, X trend, Y trend. Okay, once you fit, okay, then you can use it to do the predictions. Okay, so I have keep some for testing. S test is for testing. Okay, so I put in this test value into the model that we have built using the data. Okay, so the output now will give you either LRT or car. Okay, 0 or 1. Okay, the down here is the predict, up here is the original. Then you can make a comparison how many is correct. Okay. So can you try this Naive Bayes classifier in your Jupyter? Okay, so open a